Hello and welcome to this TGA digital video on how to create an animated force field shader using ShaderFX in Autodesk Maya. With this force field shader, we'll create several animated effects, including procedurally generated ones. If you're not familiar with working with ShaderFX for Maya, check out the link in the description below for a video where I show you how to get started with ShaderFX. So let's get started building this shader. In this lecture with ShaderFX in Maya, I'll show you how to create an animated shader like this one to create a sort of force field effect, if you will. Now, this shader is actually just a geosphere, which looks like this, and a polygon plane. And it's only using these two textures. So the polygon sphere is using these. I've stacked all of the UVs on top of it. You could go for a geometry approach as well. Depends on, I suppose, your end use case. And also this here gray pack texture, which is essentially three different noise patterns. Each of these patterns is in the RGB channel, so you can utilize them to break up repeating patterns. And the pulsating effect on the outside is actually just procedurally created. So let's get started with creating a similar effect like this one. Let's start with doing the shader for the sphere part. So I'll go ahead and select my polygon plane and just hide that. Now, I'm not sure if you noticed, but with this sphere, we don't have this grid pattern as visible in the center. So as I move the camera around, you can see that in the center, this grid pattern isn't as apparent. And the way that works is that you use a dot product between the camera vector and the surface normal. Now, for those who might not know what a dot product is, I'll just show you real quickly with two images. Now, this image describes how a dot product works. You feed two vectors into the dot product, and in our case, since we're using a 3D vector, a direction, those vectors will consist of three values, such as, for instance, surface normal. Now, the red arrows on the polygon sphere represent the surface normals. They're all pointing outwards towards their face direction, if you will. The blue arrow indicates, in our case, it could be the camera vector, but it could just as well be a light vector or something similar. And if you take these two vectors and do a dot product, you get a value ranging from -1.0 to +1.0. And if you look at the example image, you can see that the exact opposite vector of the blue one will get a value of -1.0, and a vector pointing in the exact same direction gets a +1.0. And those vectors which are 90 degrees from the incoming vector get 0.0, and etc., as you can see in the images. And if I jump to the next image, you can see as I flip the blue vector at the left, the values will work in this way. Now, since we're using the camera vector for our shader, as we move the camera around, we will always have the surface pointing straight towards the camera in black or white, and as it starts to rotate away from the camera in the silhouette of the shape, for instance, it will go towards 0.0. So that's the base of this shader effect I just showed you. Let's go ahead and create a ShaderFX material on our geosphere shape here. So I'll right click, go assign new material and choose ShaderFX shader. I'll click the open ShaderFX button to enter the editor, and I make sure that I'm in advanced mode. I'll delete this part as I want to start from scratch. And as I showed you earlier in this course, I'll use my baseline group. And if you haven't seen this part of the course, this is just a set of 5 core nodes that you need to display any kind of color on your shader. So I can plug in a float 4 here, an RGBA data stream, to show color in the viewport. Now, I want to use a dot product, which I just described to you. There it is. The dot product takes in two input values. So I'm going to use the camera vector, this one. And I also want to use the vertex world normal, this one. And make sure you choose the vertex world normal under input comments. Don't confuse it with the vertex normal here. You want this one. Right, so I'll take the world normal in one of these. It really doesn't matter in which input you put them. And I want to use the normalized camera vector. Normalized means that the vector that indicates the direction will always have a length of 1. And that does matter when it comes to the output of such things as a dot operation. So in this case, I want to use the normalized vector. Right, so I should actually have a result as in my example images where I would get a ranging value from 1.0 to minus 1.0. Now to show this in my baseline group here, I have to plug in a float 4 and I have float 1, so I'll just use a vector construct, this one. And I know from experience that to save a bit of time and not having to connect this 3 times into x, y, z all the time, I usually just, and this is just a quick workaround, I usually just take a math node of some kind, like an add operator. You can remove this in the end. This is just for me showcasing the dot operation for you. But I take this node, I just set this to 0.00, which actually means that the add operation doesn't affect anything since I'm adding 0.0. And then I connect this here. Now the neat thing here is that now I can easily disconnect any float and just connect the float here. I don't have to redo this 3 times, which gets a bit tedious after a while since you constantly might want to check for debug purposes just to see how's it coming along, what does this float look like. So let's see what kind of results we have with this setup. Alright, so here we go. Yeah, does not seem to work as I had expected actually. Let's change the background color, because I was expecting here to have the camera vector move around with the camera, and to some extent it does seem to work, but I'm thinking I've done something wrong here. Let's just try once more to connect this, see if that makes a difference. No. Alright, let's try the camera vector instead. I don't think it should be the camera vector, no. Okay, that didn't make any difference. Right, so I'm a bit stumped here. Oh yeah, right. Silly me, I needed to connect the float 4 as well. See, I'm human as well, I make mistakes as well. Right, so the normalize, world normal, everything should work fine now. Yeah, here we go. Now you can see that I have this big area which is seemingly completely white here. It should actually be only just the face pointing straight toward the camera, which gets 1.0, and then it transitions from 1.0 to 0.0 out here at the rim. And on the back side, which we can't see since we're using the camera vector, I should have minus 1.0 at the very face, which is pointing away. So one thing you could do here is that I like to add in a power of math node, and I put the power of math node in between here, like so. And if you know how a curve would look like with the power of operation, you might be familiar with working with curves in a 2D editor such as Photoshop. It's basically having a curve which will have a shoulder upwards or a shoulder back downwards or heel or whatever it's called. And the way you get that is if you use a value which is in between 0.0 and 1.0, you will get a curve which is going to be like this curve, like a top curve, if you will. And as you proceed to go higher value than 1.0 here, you will have a dip like this instead. And since I have a very white result, I'd like the black area here to fade in more, to be more pronounced. I want the curve to go like this with a dip. So I need to increase this value. For instance, like start with 2.0, and we can try it out and see how that works. Now this is where I save time, as I mentioned. I can just put this in the add. If I didn't have this add, I'd have to add this to X, Y, Z. I wouldn't have to, but it's nice to get a black and white result. So I'll just select this one, keep it selected, and as you can see, the power of node, if I put this at 1, now we don't get any difference from the power of node. But as I increase this value, you can see that the black will be more pronounced and the white will be smaller here. Right, so this is going to work as our transparency, if you will. So the next step is to build the transparency feature here. And I think, but we can see as we add the transparency, I'm fairly sure that white indicates that it should be visible. So I probably want to flip this around later on to make sure that I have white here and black in the middle. But let's continue with how you add transparency to the shader. Now, to add transparency, you have to actually modify what's going on in the baseline group. And as I mentioned when I spoke about groups earlier on, since this is a reference to a group on disk, if I were to edit this one inside and keep it as a reference, those changes would be lost even if I save the scene and reopen the scene. So in this case, I want to select this group, go to the group menu and choose Make Group Unique, which is going to remove that little R symbol, and now all of the information in here is stored in the actual file and not be used as a reference, if you will. So now we have to add something called a state setting node here to get transparency to work. And you just search for state and use the state setting and connect this one to the state setting in the pass node. Now you have to choose the state settings node, and I think I might start working with this property panel. I might have mentioned it before, but I do prefer having two screens and putting my attribute editor on the second screen. That way I can get more actual workspace here when I have a big network. It's easier to get an overview. But since I'm using one screen here, I'll see if I can get used to working with this property panel. So anyway, choose the state setting. Here where it says options, you want to change to Premultiplied Alpha blending. As you change this one, it will start using the alpha channel, which comes into this stream here, as the mask for what is going to be visible and what will be transparent. Now, this is a key thing here to notice, that it says Premultiplied Alpha blending, not just alpha blending. That means that we have to multiply the RGB stream here, the RGB part of this stream, with the alpha channel. That basically means that any area that is going to be transparent needs to be black in RGB. Otherwise it will be visible. We can see if we can see the difference, if it's possible to tell. It should be, I suppose. But let's see what this is going to give us. So right now we don't have anything in particular feeding into the alpha channel. You can see that this vector is just built up of the RG and B having the results from the dot operation stored in them, and nothing connected to the alpha channel, which means that it's going to use this uniform value that I set here, this parameter for the alpha value. So to make this more interesting, we could delete these, for instance, and connect this one to the alpha channel, and instead we could choose a color node, color, and use that color node as our color here. So I can connect that to the XYZ, which translates to RGB, and this one into the alpha channel. And let's select this one while we're at it and use a more interesting color, like this one, for instance. Right, so let's see what we've got going on in the viewport. Here you go. This is probably the issue I spoke to you about with the Premultiplied Alpha. I think if this worked properly as it should, we'd have just the middle part visible and then it fades away to the end here. And to get this working correctly, the Premultiplied Alpha, you have to take the alpha channel and multiply the RGB channel with each other. So I'll show you. We can move this to the side. We'll need a multiply node, multiply. You take the RGB data stream, you just multiply with the alpha channel and use that instead in the RGB. And now we have results that look like this. And as I switch to the background, you can see that I actually have transparency going on here. Right, so that's how you get transparency working with ShaderFX. And don't forget the pre-multiplied part. Now, as always, transparency is a bit dodgy with Maya. You have to realize this. And as far as I know, it's always been a bit dodgy, as far as I can remember, in all versions previous in Maya. I've not seen anyone telling me that it works flawlessly and you just have to know how to work with it. So I think it is a bit iffy and you should just be aware. Right, so if we want to flip this around so that we have this part not visible and the rim visible, we'd have to flip the results that we got from the dot operation. Now, you could flip it here or after the power node. I don't think it should matter as far as I can tell, but let's see. We can take this invert minus operation, 1 minus operation. Now that will take 1 minus the value you feed into here, which you could describe it as you flip the value around 0.5. So an input value of 0.3 would give you an output of 0.7. An input of 0.1 would give you 0.9. So you flip it around the 0.5, the middle if you want. So if I connect this one here and then this one here, we should essentially have flipped it around. And now we've got this kind of result. And as you can see, this is the base of the shader I showed you earlier. You would have the hexagon pattern more pronounced here than over here. Now to get the hexagon pattern, and this could be whatever kind of pattern you wanted. If you went for a geometry approach, you wouldn't need that hexagon texture. You could just model a thickness here of the lines and remove the inner parts, and it would be fine just as it is. But since I want to show you how to use a texture in here, let's go for a texture map, this one, and we'll take the result here from the dot product. I can take from here, and we want to multiply it with this texture here. So let's see, we need a multiply here, and I want to go ahead and load this hexagon texture I showed you earlier. So this one, no, that's not it. It's strange that it defaults to this one, and I don't have my source images here. I think the attribute editor which I'm used to using here gives me this dialog, which is easier since I can go source images here, and I'll have it over here, hexapenta with alpha, this one. And I think that if I'm not mistaken, I have the information I need in the alpha channel. Let's see, we might get a preview from there. Yep, I think that should be fine. Let's see how that translates if I use that as well. So the only thing I did here is I took my texture, which has a black and white alpha channel with that hexagon pattern, and I just multiplied the previous string which I used for the alpha value, the transparency. And I have this going on instead. Now, it's a matter of tweaking the values here to get it stretching further in or further out, or making it more intense or whatnot. An easy thing could be just to multiply, for instance, the effect of the texture here to get it more intense at the edges here, or just change the float operator here, which goes into the power of, to change how far it stretches. So for instance, as I do like this, you can see that it creeps further inwards. So it's just a matter of taste. And one thing to keep in mind here is that if I'm planning on using this in a black outer space environment, it's a good thing to set the background to something more like your intended background, because it makes a huge difference if I view it with a light background or a dark background. So if you're going to be tweaking the values, set it to an appropriate background color or value. So let's say that I want it at something like this perhaps, and we could also try seeing what happens if we just add a multiplier value here if we want. And I could just say, let's just set it to 2.0 to start with and see what that gives us. So that should make it more intense here, and at 1.0 it's like not multiplying it, and 2.0 you can see that it gets more intense. If I really went overkill, you see that you start getting these visual artifacts and issues, certain, especially at the edges here. So I don't want to go that far, but maybe a value of 2.0 works fine for my purpose here. And I think, yeah, I think I might leave it like this. So we just got the transparency working here, and the next step would be, well, there are a few steps. One thing I did, as you could see in the demo I showed you earlier, I had it rotating just a bit, and it seems to be rotating stepped now, which I don't like. There we go. I had it rotating a bit like this. Not way too quick, but I did have some rotation going on just to make it more visually interesting. And you could probably do that with the shader. At least it would be easier if I went the geometry approach with this outline. It could be a bit harder as I've created this one, and I thought it was just a bit easier to just actually rotate the object. You don't have to do everything with the shader. So if to add that, we could just rotate it a bit here, but I think I'll save that for later. One other thing, which was probably pretty subtle, I'm not sure if you noticed in the earlier demo I showed you, but I did have some effect going on here, which would be sort of like a noisy pattern which will move across this here force field, just to give it a feel of there being active energy which varies in strength or has a life of its own, if you will. And to add this, I used one of these here gray pack noise textures, as I mentioned in the beginning, and I'll show you how that works. So I want to go back to the ShaderFX editor. We can have just the perspective. Go to the ShaderFX node and click Open ShaderFX. And here we go. So the other texture I spoke of, let's go for a new texture map here, is the one called, I don't like this property panel. Here we go, source images. It's called Gray Pack, and I have one which is more sharp and one which is a bit more blurred, and I think I'll go for the blurred one. So there you go. Now to recap what I said, this is just from Photoshop, and I just used render clouds. So I did one render clouds in the red channel, another one in the green, and one in the blue channel. And then I think I just added some Gaussian blur. The nice thing about this is that I now have 3 different noises I can use. Because if I only had one noise and stored the same information in red, green and blue, that would be a bit wasteful. And the nice thing now is that I can use the red for one case, the green for another one, and the blue for the other one, for a third case. And it would be less likely that you would recognize a certain unique pattern repeating itself all over the place, since I have different patterns in these, if you will. So what I could do at this point is add yet another multiply in between here, and then just multiply in the results of this and see what happens. So let's start with that. Let's add a multiply. There we go. I'll put it there, and then let's take the red channel, for instance, and just connect it here. And let's see if we can see a difference. It will be static now since I'm not moving the texture around, but let's see what this is going to give us. So here's my noise pattern. I'm not sure how much of a difference you can see actually. Let's see if we can have the ShaderFX editor open and bypass it and see if we can see difference. This is without the noise texture, and this is with the noise texture. Now it might be hard to see an exact pattern going on here in the noise. I for one did notice that it got less intense. That was the general feel of it. And but as we start moving it around, you will probably be able to pick up on certain noise patterns. Let's go like this. Right, so I think actually with this sphere I've gone ahead and changed the normals. I just want to make sure that I'm using soft edge here. Yeah, okay. Yeah, this is alright, sorry. I'm mistaken. This is not due to any soften or harden edges. and it shouldn't be since I'm not using them for lighting. Actually, we have another issue which we have to solve here, which I'd forgotten about, and that is we're using a texture which looks like, this is what the texture looks like, and since I have stacked UVs, they're using the same texture data, and as I'm moving a noise pattern, which is a whole complete noise pattern, I'll get the same repeating noise on each of these hexagon faces and the same repeating noise on each of these pentagon faces. And that's why we see, if you notice, that you can see some hard distinct edges in between these patterns. And a workaround for that is that I actually used the screen space position as my UVs for this. Now that might be a bit abstract, but if you think of this here screen area here as the UV area, you would have a U value of 0.0 here and going towards 1.0 here. And you would have a V value of, might be 0, I'm not sure where it starts from, but 0.0 down here, and it goes towards 1.0 up here. And I used that as my UV input instead of the actual UV map on the model. That way I get a unique representation of the entire object when using the noise pattern, instead of this issue I have here. One drawback could be, if you find that the drawback might be something you find cool, is that if you were to rotate around like this, you might actually see that that noise pattern does not seem to stick to that point on the sphere. It moves around with the camera. But that, I'm not sure that you would be able to pick up on that, to be honest, since it's such a subtle effect. So I'll show you how that works. You can use screen position, this one, and the screen position gives you a float too. And that you can plug that right into the UV here. And as I do that, you can see that this issue I showed you earlier with the hard edge here in between the noticeable edges, it seems to disappear, right? And now we should have a more noticeable noise pattern going on here. So that's one of the things we want to do. Another thing is we want to get this moving. We want to animate this effect. Now there's a few ways to do this. You could, for instance, offset it, as in moving it to in a certain direction at a certain speed. You could also rotate it, and there are some prefab nodes for this. There's one called UV Panner, I think. Yep. This one will let you translate or move it to the sides or upwards or whatever direction you want. There's also a rotator, if I'm not mistaken. Yep, UV rotator. They can be a bit costly if you use several of them, but it's a nice thing to add. I think especially the rotate one would be a bit more costly, but this one is essentially just taking a time variable. If we add time here, which would increase as we play back in the Maya viewport, and just add that to the UV stream. That will give you the effect of the texture repeating itself, given that you have using the wrap here. The texture will repeat itself as you move the UVs outside of the 0-1 range, if you will. So I think it's more interesting to show you how this actually works than just using the prefab ones. So I think I'll just go ahead and delete these, and I'll just show you. This is the time node. The time node will give me an output value which will increase as I'm using playback in Maya. So if we were to take, for instance, let's use a vector component to break up this float2 data stream, and we'll need a vector construct later on to rebuild it. So I'll use that one there. And let's say we wanted to move horizontally like this from side to side, or actually just in one direction horizontally. So that would be probably the first float value here. The X should represent the horizontal pixel position, I suppose, and Y the vertical position. So let's grab an add node, for instance, here, and let's take the X, which should be the horizontal position, and add time, and then plug that into X. and let's say we don't want it scrolling in Y direction. So we'll plug Y straight in like this. And you can even see, as I'm updating the viewport here, you can see in this small preview here, I can make it a bit bigger. You can see that I get this live preview, that it updates and it scrolls to the side, which is kind of cool. But let's see what this looks like in the viewport instead. So if I hit playback now, you can see that you have this pattern going from right to left, I take it, right? Yeah, so I probably have 0.0 here and 1.0 here, and as I'm adding, it's moving in that direction. Right, so one thing you could do here is you might want it moving the other direction, or upwards and downwards, or diagonally. And another thing which might be more important to change is the speed of this process, because right now I think it's moving too quickly for the kind of results I want. So I want it more slow moving, and an easy way to change that is just adding a multiply node here at the time node, which essentially would give you slowing down time. Think of the Matrix movie, for instance. So I'll just create a bit of space in between here to separate them. This is the transparency part, and this is the noise pattern in the actual force field. So I want to add a multiplied node here to slow down time. So multiply, let's add a multiply here. I'll take the time in the first input. In the second input, I'll go ahead and write 0.5. Let's start with that and add that here. And let's see what that looks like. If I select this one, I should still be able to change it from outside here, I thought. Whoops. No, I don't want to move my Spotify around. This one. Ah, yeah. I think it's because I have playback running. There you go. Yeah, I can still see it, and I still feel that it's moving just a bit too quickly, so I think I'll put this down to 0.4 or 0.3 or something like that. And that's fine for now. I think I'll leave it for now, and as I'm adding more effects and finishing the work, I might come back to this and change this later on. And if you want, it might be a good idea to actually start setting nodes for your nodes, because as this network gets bigger, it might be hard to look through it and remember what each part did, especially if you leave your project and then open it several weeks later. So just for making it a bit easier for you, you could just write on top here what this node does. So this one is actually quite easy to understand, but still, I'll show you. If you select this multiply, you can add here in the note parameter, you could add time slow down, for instance. There you go. Same thing for the other ones here. You could add at crucial nodes, or depending on if you feel the need for it, you could add more nodes, such as inverting the dot result, for instance. Right, so we've now got this effect going on, this one, and we're almost done with this part of the force field effect. There are two more things I want to add. I want it to rotate, as I talked about earlier, and also I had a subtle effect, but still I had it scaling a bit, so it would grow bigger and then smaller and bigger and smaller. Not that much that you would notice super easily, but it did add some effect. And I think that's the whole idea of doing effects like this, that it's probably built up of several different parts, and each part itself doesn't make a super huge impact that you're able to pick up on it that easily. But as you combine all of them together, they do add one big resulting nice effect. At least that's how I want this working. So to animate the scale of the object, you can do that with this input here in the baseline called Object Vertex Position. That feeds into the vertex shader here. We connected that when we created this baseline group. And to modify the vertex positions, you can just feed in values if you want to add or subtract or whatnot, and you will actually move the individual vertex points away, which is really cool if you start doing nice animated effects. So I'll just show an example. I'll go ahead and find the vertex world normal. Now the vertex world normal is, I'll show you, if we enable them, I have them over here, vertex normal. That's the direction of the vertex, which way it's pointing. So I can actually access these directions and use them as the direction I want to push the vertex in. That would essentially just scale the sphere upwards or downwards. So if I just take these and I don't think it's as easy as doing this, we'll see. I do need to probably, I think I actually need to get the position values to start with. So I'd get the vertex world position as I think I'm overwriting the position values when I feed into it. It's just not adding the world normal directions, it's replacing the actual position with these values stored here. So I want to take the existing world position. If we just connect that, it shouldn't make any difference, and I want to add this one in between here. So if I select add and add the world normals in between this one and then connect here, it should be as I'm scaling the object. There you go, you see it made a huge impact. If I change it back, it's scaled upwards by quite a lot. And if we wanted to make this effect less subtle or not as much, you could, as with many other effects, you can just multiply the effect. So if I take the existing world normal direction values, I multiply those, and then I type in a multiplier value here. So let's say we just want to move them a fifth of the strength they had before, or the distance, the move distance, and then I connect it here. And now you can see that as I change this value, you can see here in the background, if I lower it, you see I don't move it away as much, and if I go higher, it moves away more. So now I have a effect multiplier, if you will, here of how much I want to move them in their normal directions. I could actually go ahead and choose a negative value here as well to scale it downwards. Now this is all nice, but I'm just doing this static now. We wanted to animate, to pulsate a bit, and one easy way to do that is to use a sinus function, which is just sin, S-I-N here. And the scene works, if you're not familiar with it, you input a value here and you get a value which will go as a sinus curve. It goes like this. You've probably seen them before. You will get a value out here. So if I put time, which will always increase, this one will always go as an animated effect, which will give me a value of -1 here at the bottom and 1.0 up here, +1 up here, and it will go back and forth like this all the time. So it's good for repeating effects, and you get this smooth in and smooth out as well. So let's have a look at that. Let's take time. We'll use time to drive this sinus operation, and we'll use this one to plug into here. And I think that we'll probably need this one still to have a separate effect control. So I think I'll just choose yet another multiply and add this one here, add the result of the sinus in there, and connect it over here. Now this should give me an animated effect which scales this, as you can see. Now I don't want it to move at all this much, so I need to tone down on the effect. And you might also want to, as we did previously, scale how quick time moves, as this is going probably a bit fast for what I'm looking for. So I'll go back to ShaderFX. I'll take here, move the time here. I want to add a multiplied node to slow down time. So I'll add this here. I'll type in 0.5 for instance, to cut the speed of time in half, and I'll decrease the effect value here of 0.05 for instance. Let's see what that looks like. So that's definitely a lot more subtle, but it's still moving a bit too fast, I think, too far, and probably a bit too slow as well. I regret going that slow, so I might take it to 7.5 for instance, and still moving too far in my opinion, so maybe 0.2 or 0.1 even, 0.01. Let's see. Yeah, I do want to start rotating the sphere now and see how these work together, as rotating it and scaling it will give a different result than just watching it not rotating and scaling like this. So I think I'll go ahead, I can close this one down, or actually I think I'll disable the vertex normals again, like that, and I'll go ahead and animate this sphere as well. So choose one direction you want to animate it, or several for that matter. I'll go ahead and choose rotate Z for instance, and put it at 0 in the first frame, or at the start, and then just select anywhere. I'll go into the graph editor and edit this later anyway. And I'll choose 360 degrees for instance. Key selected. Now I want to open the graph editor to work with animation in Maya. I want to show this curve, and I don't want this spline-like transition between the values, which is the default input-output tangent in Maya. So I'll choose both of the points, and I'll choose this linear one. I want this result. Now I've got something called infinity enabled in the graph editor. You can go to view and check this option here, infinity, which will show me these dashed lines here. And I want it to continue rotating in infinity. So there's an option under curves called pre-infinity and post-infinity. So I'll set both of these to cycle with offset. And as I do, you can see that it's going to continue in that same speed of rotation, if you will. And also post-infinity cycle with offset. So now as I'm playing back, even as I go past this keyframe, it will continue rotating. So this is what I've got right now. And probably a bit too fast for what I'm looking for. So to change that, I need to have it selected, and I'll go ahead and choose this one, and either move it downward to make it go slower, or move it to the side. It's actually the lean angle here, which is the interesting part. That's the rotation speed, if you will. So maybe something like this would be better. Might even go a bit slower. I need to have it selected, and I might actually want it to rotate downward, if you will, or rotate like this instead, to be honest. Or you could just change the camera view for that matter, but let's see what that looks like. Yeah, that's more the effect I'm looking for. So you know, I might fiddle about. Actually, I've used these exposure and gamma ones also before, just to push it up a bit, the intensity or the look of it. I think I'll leave that one like so, and maybe put this one at 3. Yeah, but I think I'm quite happy with what that looks like. This is pretty much, or I think almost exactly the same as the results I showed you. Next step will be to add this plane here and get this pulsating beams effect going on here as well. So let's continue with that. Alright, so now we're viewing my original example again, and the reason is I want you to see how the Forcefield Glow effect looks like. So if I go ahead and hide the sphere, this is what the plane looks like. And if I show the grid as well, you can see that one key feature here is that the plane should always be oriented towards the camera to sell the effect of this being a glow which is present all around the sphere, if you will. And this should be fully possible to do within the shader, but I prefer doing it with Maya instead, since it's easier, and I'm not sure which way would be preferred in a game engine, to be completely honest. But to get a plane like this aiming towards your camera, you'd use the aim constraint in Maya, and the base for making this shader here, this is a completely different ShaderFX shader, or not completely different, but a new ShaderFX shader. And the base is to have a circular ramp which stems from the center here of the plane and shifts as it goes towards the corner here. So think of it as a circular ramp. And you use this as a mask, if you will, or as a positioning system to say, hey, where am I going to cut this big hole, or where is the beams going to fade off and such. And we're going to create this this gradient or ramp procedurally. That is, we won't use an image to generate this ramp, or to have this ramp available. We'll generate it by shader code instead. And I'm going to show you 4 example images to explain how this concept works. So to procedurally generate a circular gradient, think of a UV space in Maya. You know, the UV editor where you have the top right corner, which represents the positive quadrant, if you will, where you have both the U and V going from 0.0 to 1.0. Now, if you go ahead and take those UV coordinates and you subtract 0.5, you get this effect. Essentially, you're moving the origo, or the center point where you have 0 in both axes, you're moving that to the center of the same space as before. So now we have negative 0.5 at the very end and positive 0.5 at the other end. Next step is that when you get different pixels that you're going to sample, say that you want to sample the top left blue position there. You're currently sampling that pixel on the polygon plane, and you get UV coordinates. Those UV coordinates, if you subtract minus 0.5, you might end up with coordinates like those in the image here, negative 0.3 and positive 0.4. What you then do is that you take a length operator, and the length operator is used to measure the length of a vector or a line, if you will. So imagine that you draw a line from the center of the UV, the origo, 0.0 point, and you draw it all the way out to where the coordinate is located. Then you measure the length of that line. And as you can see in the 3 example points, you get different lengths. Now, think of those lengths as brightness on a gradient, on a circular gradient. As you can see, the length will be a lower value towards the center or the origo, and it will be a greater value the more it goes towards the corner or the end of the grid, if you will. Now, if you show this as a visual result, this is what you get. And now we've essentially created a procedural circular gradient. It has perfect resolution in that you can continue to zoom in infinity, if you will, and you will always have good resolution, if you will. And you can save texture memory as well by doing it this way. So we'll go ahead and create this method in ShaderFX. Here's the sphere and the shader we built earlier on. And now we need to go ahead and create a polygon plane that we can use as our pulsating beam effect out here. So I've created a polygon plane. I think it's due to transparency, I can't see it properly. Maya's always had an issue with transparency and not having it working correctly always. So what we need to do now is first to create an aim constraint, so we make sure that the plane is always aiming towards the camera. And the way I'm going to do this is either through the display menu or through editing with the object axis here. You have to see which axis do you want pointing towards the camera, and preferably also an up vector. So I want positive Y to be pointing towards the camera and positive Z to be my up vector, for instance. So I'll go to the animation toolset or menu set, and under constrain and aim. And we need to set the aim vector to be positive Y and the up vector to be positive Z. There we go. And now you need to select first the controlling object, that is the perspective camera in my case, and then the object which is going to be controlled, which is the polygon plane. And then let's press apply. Now if I move the camera around, the plane should always be facing the camera. And this should work well for the way we want this effect to be visualized. So I can go ahead and close this, and I'll switch to hardware textured mode again. Now, as I mentioned, the transparency does not seem to be working properly, but imagine if the transparency did work, sometimes it does, I'd see the polygon plane through here, and that's something we need to sort as well. So I think we'll hide the sphere for now, and we can show it later on. And I'll go ahead and hide this example object I had contained within there. And let's select the plane and create a new ShaderFX material. And this ShaderFX material, we can start with creating that procedurally generated circular ramp, which I showed you in the example images earlier. So I'll go ahead and go to the ShaderFX shader here and press Open ShaderFX. And as most of the shaders so far, I want to delete this Swiss Army knife shader here and go ahead and create my baseline group. This one. So if you remember, we go for the UV of the object, and to get the UV of the object, we search for the node called UV set. UV set will output the polygon object's UVs. And the next step after accessing the UVs is to subtract by 0.5. So I'll need a subtract node, and we'll connect the UVs and then subtract 0.5. Make sure that you don't write minus 0.5 here, because the node itself does the minus operation, so just 0.5. And now we've offset the origo to be in the center of the UV space, or in the center of the plane. And next thing to do is to use a length operator or operation. So length, there we go, which will give us the length of that two-dimensional vector for the sample point. Now this here result should look like the gradient we want, as you can see. Yeah, this doesn't really make much sense, but here we're getting the results that we want. So we could start to visualize this on the object as well. And let's do that just to show what it looks like. So I'll create a vector construct. I'll connect the float 4 here. In case I want to show different parts, I'll do the add node trick again. You could do any kind of math operator or similar node which doesn't actually affect the data stream. So I'm going to add 0.0, which makes no difference, and then I'll connect this to X, Y, Z. There we go. And if we look in the viewport, this is the results we have. And I think I'll switch this to raw as well, because if I leave it at sRGB, you'll get predominantly white or bright colors here, and I want to see the raw results, so I see that linear transition here. So I've got 0.0 at the absolute middle and somewhere around 0.78 if I'm not mistaken up here, which should be fine. So the next step which we could cover is that we have this helix, the sphere, which is, I think it's this one, right? Yep. Let's see, what's this one? Hold on. Oh yeah, I've got this old spaceship lying around. I don't need my helix. The polygon sphere. Nope, don't need that. Oh yeah, I have a big background sphere. Here we go, this is the sphere we created. So I want to limit this gradient to only show on the outside of the sphere. If the transparency would work now, I would see this gray gradient in here, and I don't want this pulsating effect to show on the inside, just on the outside. So I need to find exactly where to cut on this circular gradient, if you will. And you could do this in a few different no, that's not right. Here we go. I think I selected another object which had a ShaderFX shader. Here we go. So one way to do this is to use a step node. A step node could work fine. So step, and I think I want to put this one here and a float value here. let's see, you might need to switch these around depending on which area you want white and which area you want dark. So I'll connect this here, and let's connect this just to visualize. And with this float value, as I lower this float value, you can see that it's going to give me either true or false, if you will. So I just want to find where this edge is here. Now to make it perfectly match the sphere, I'd actually have to, if you remember, we scaled the sphere. So you'd have to scale the plane as well, or offset where that cuts if you want it exactly aligned to the sphere all the time. Now, I'm not sure I'm going to be that picky in this tutorial, but I just want to mention it if you do want to take care of it yourself. So I think I'll settle for something like matching it at this point. So let's see, do I need to go bigger or smaller value? Yeah, I need the smaller value. So let's just try typing it in here. So 3.4 perhaps, yeah, that's about it. 3.35, let's settle for that, 5, there we go. You can always go back and tweak this later. So 0.335 is my magic number where this circular ramp exactly matches the sphere. So I can go ahead and hide the sphere now again. And we'll be using this later as a mask for where the effect is going to be shown. So I'll select my plane again, make sure that you have that shader here in the editor. And the next step could be that we want to import this here noise texture, the same noise texture we used earlier. So I'll go ahead and select a texture map. There we go. And with the texture map, I'm going to browse for my source images and select my gray pack. I think I might go for the sharp one this time, the not blurred one, that is. And for UVs, I want my, let's see, I want my UV set. There we go. And I want to offset this as well, similar to what we did earlier. I want to subtract like this one. So you can go ahead and copy paste that node if you want. Be careful not to cut and paste. If you cut and paste, it will close the entire ShaderFX interface, and I think it actually cuts out the entire ShaderFX node and keeps that in the clipboard. So you don't want to do that. So copy paste works fine. Be aware of the cut command. I'd advise you not to use it. So I connect this here. And the trick here to get these kind of beams that come from the center and project outwards, you can use a normalize node here. Normalize, and I'll show you what that looks like. Normalize, and we connect this into the UV, and we get this kind of result. So that's a neat little trick to get this kind of effect. Now, we want to also move this around or get it animated, and one way to do that is actually to offset the UV values. So similar to what we did with the spherical force field effect, where we had the noise texture panning. I think we had it panning downwards, if I'm not mistaken, or was it left to right? Either way, if we just pan in one direction here, that will move the gradient or the noise pattern around, and it will make these beams seem to be animated and shifting color. So I'm going to go ahead and do that now. And I think that we want to do this either before the subtract or after, it doesn't matter, but before the normalize operation. So I'll go ahead and put an add node here. I'm not sure, it might actually work after the normalize as well, but my gut feeling tells me this is the way to go. So let's try that out. So I'll put my UV input here, and I want to use time once again as the driving factor, as the time node is an easy way to get a value which will keep increasing all the time. So if I take my time and just add it here, I think I might just want to, no, let's see, I don't think it matters that much, as this is so abstract. It doesn't really matter if it's panning diagonally what direction. I was going to say I wanted to add it only in one direction, either U or V, but now if I add to both of them, I think the actual noise texture would pan northeastward, if you will, in that direction. But for this purpose, I don't think it really matters that much. So let's see what that does. No, okay, yeah, that's not working the way I thought it would. I might actually be wrong about the normalize. Let's try adding this after the normalize. Yeah, okay, yeah, that's working better. Yeah, all right. I think I was getting way too large numbers, and the normalize made them all pretty much the same color, if you will. So I'm just moving this around to give you an idea of what it would look like when playing animated. You can click this here, play animated shaders, and it should animate. Be aware though that if you have lots of these small previews playing, it will have a performance impact. So it can be a nice idea to limit only a few nodes showing like this, or at least close them after a while, or don't have this play animated shaders running. Next step is, I think that to mix this up a bit, I think I might want to take two of these nodes and combine them together. Otherwise we might actually recognize the pattern here, and I want to break up the repeating factor, if you will. So one way to do that is to take another texture sampler, and I'll go ahead and copy paste here, and I'll place that over there. I want to do a similar thing here where I use the UV set, but there's one difference I want to do, and that is I want to subtract instead. So I don't want to add node, because then I'd be pushing this in the same direction. I want to subtract instead, just to vary it a bit. So I'll use a subtract. I think we should be fine with using this same output here, and we'll take time here and subtract, and then plug that into the UV. And now you'll see that they seem to move in different directions, if you will, and we'll combine this result just to break it up a bit. We'll have to play it back later on and see the speed of this, but as we did with the other shader, we probably want to add some kind of time multiplier here later on, just to set the speed of this effect. Now, I think that we want to take two of these channels and multiply them together. I will just be using this as a mask, if you will, or as some form of distorting the gradient. So we'll take a multiply node, and since I'm just going to use it as an effect multiplier, if you will, I'm fine with black and white results. I don't need this colored result here. So I'll take the red channel from this one and green channel from this one, for instance, or even blue, just to mix it up a bit, since I have different noise in the different channels. So now I'll have an effect that looks like this. There you go. And it's really hard on this one, if you ask me, to see any kind of repeating pattern. On this one you might recognize some parts repeating, and this one breaks it up a bit more. Right, so next step we want to, let's see, I think it's better if we visualize this result rather than the step operation at this point. So let's see, if I just take this one, I'll move the step down here for now. We actually want it to go in the other direction, right? We want it to be more intense near the sphere, near the edge of the sphere. Let's see. Sphere, there we go. I want it to be more intense here and fade outwards here. So therefore I want it to be whiter here and fade to black out here. So that's what I'm going to try to transform the values I've got going on now to have that look. So I can go ahead and hide the sphere again. I think I can actually go ahead, let's see, oh, I've got another shader here. Here we go. I can actually go ahead and take this step node here and multiply this one by that one to get the correct kind of look I want. So I'll take a multiply node, and I'll place my multiply node here. I'll take this result and that result, and I'll visualize this instead. Yeah, yes, correct. We're going to have a bit differing result once we flip this around to have white here and go to black here, but this is what we want in the end. So let's see. Oh yeah, sorry. Here we go, my bad. Yeah, that's more correct. Should always be black there. had to think it over a bit, but since I have black here, you'll be multiplying by 0.0, and whatever result I have going on here, if you multiply it by 0.0, you will get black. So that's more correct, but we still want it to be whiter here and fade to black here. So we need to transform this, and I think the way we want to do that is we can start by inverting it. So I can once again use the invert 1 minus node to just invert it around 0.5. we get that kind of result instead. So it will start to look more correct, right? But I want it to be really intense here and to fade out sooner. I don't want it to cut against this. It has to be black, pitch black, before it hits this edge here. Otherwise I would get this kind of edge here, and it would not sell the effect well, not be visually correct, if you will. So I think one way to do this is to use an add node. So first thing I want to do is just add enough to make sure that I get perfectly white color here. So I'll do that just by trying out and seeing the visual result. I guess you could calculate it theoretically how much you needed to add, but I'll just do it by eyeballing it, if you will. So if I add something like 0.3, and it can be a bit tricky to be able to tell, and I mean, in the end, if it looks good, it is good. It doesn't make that big of a difference if you have 0.9 or 1 here, I think. But I think this is good enough for now. We'll be able to tell better once we add the next step here. And I think the next step, I would go for a power of node. Or you could go for a multiply node also. Depends on how you want the fall off to be here. So let's try a power of node and see what that's going to do for us. So I'll connect power of. The power of, we used that earlier. It's the curve-like modifier where you could either have this dipping curve that goes below like that, or the one that goes above, which either brightens or darkens the image, if you will. So I'll go float here, add my float node. Connect my float node to the Y component here, and then connect this one to replace the previous connection. Now I want to increase this value to make sure that the darker parts come sooner, if you will. And I think I do need to multiply it as well, because I'll never hit exactly black if I only use power off, if I'm not mistaken. But I think I might want both solutions. So I'll add 2 here, perhaps, maybe in 3 or 4 or something like that. Maybe even higher, let's see. Yeah, all right, that's more of the look I was after. But as you can see, I think that theoretically, I might be wrong here, but if I increase this power, I'll actually never get perfectly black there. I'll get very, very close to black, but yeah, I know I might be wrong. I should shut up about it, I suppose. Anyway, let's add a multiply node. Let's see. Multiply, and I might want to multiply it in between here, I think, and then I'll add. So if I multiply this value, let's see, let's multiply it by, say, or actually, no, that won't be right either. I think we might want to subtract, actually, then clamp it or saturate, and then we'll go ahead and multiply. That's probably the correct way to do it when I think about it. So let's try that out. Bear with me here. If we subtract, let's see, subtract, and let's subtract by, hold on, let's say 0.3 to start with. And we'll visualize that result. You can see it as I'm increasing this value by how much I subtract. I'll add dark parts here. And if I subtract to the point where I can see the pitch black up here, if you will, 0.3 0.6, no, that's way too much. 0.5 perhaps. Yeah, okay, that's about it. 5, no, 4, 5. That's too much. Let's stick to 5 then, see what that does. Now I'll have negative values here. So if I multiply now, I might get away with not using a saturate here, but I could clamp so I make sure that I have 0 all the way here, because I'm actually having negative values. And once I go below 0.0, I don't see any visual difference. It might come back and bite me later on depending on what I'm going to use this for, but I don't think so. So at this point I want to go ahead and multiply the value. So I'll take this and I'll multiply it to get my white area back again. So if I, let's say, multiply by 2 just to start off and look at the visual results, you now see that I have my black here and I'm starting to increase the intensity here again. And I think that might be the way we want to go about doing this. So 3 perhaps. I think I'll need to skip this add in the end and instead use a multiply to make sure that my white reaches the correct point. So I'll connect this. I can go ahead and delete this add node. I'll look at my results out here. Let's see, I'm doing something wrong because I'm not seeing anything here. What could that be? Let's see, power of node might be my issue here. Let's set the power of back to 1 to make sure. Yeah, okay, here we go. Power node with 1 makes no difference. I'm essentially bypassing the power node now, if you will. So at this point I want to push this white area here. I'm not sure if you're able to tell, but I think I can tell that I have perfectly white here and it's reaching about this point, and then it starts to fade. So I need to push this further, and the way to do that is just increasing this multiplier value here. So I'll go ahead and put this at 5 for instance, or yeah, you can see here, it should be able to tell here eventually as well. If I go too much, 8, you can see that I've got about this width here of perfect white, at least when I'm eyeballing it. So I can probably step back a bit to maybe 7 or 6.5 or something like that. Yeah, let's try this out. And now we can add a bit of the power of node. Yeah, as I said, here's my my negative values biting me in the end part. So I think I might need to go ahead and, after the subtract, make sure that I have 0.0 all the way here and not negative values. And you can do that 2 ways. You can use, or actually several ways. Let's do the mean node actually. Oh no, sorry, max node. Max, you could use a clamp or you could use a saturate node as well actually. All of those should work. But if I use a max node and I connect this here, let's see if I can type in a value here. Yep, 0.0, and now I connect this max node here. There we go. What this does is the max node is going to choose between either the input value or this value and choose the biggest one of those values, which means that in the areas here where we have negative values, or actually we have negative values here, it's going to, let's say I have negative 2.0 here. It's going to compare negative 2.0 or 0.0. Which one is the bigger one of those? And it will choose the bigger one. So essentially, if I were to have any value lower or below 0.0 in the image, I would get 0.0, since this would always be the bigger value. So that's half of a clamp, if you will. So now I got rid of the white parts here, and I should now be able to tweak the power of node here. I can show this as well over here, right? And I want to look at my results out here to see what's going on. So yeah, I think something like 2 or 3. We can tweak it in the end and see what that looks like. And I'm just going to show the sphere here again, just to make sure that, yeah, it lines up well here. So that's looking pretty nice. So I'll go ahead and hide my sphere again. I'll select this plane, which will give me the ShaderFX shader here. And at this point, I might go ahead and actually take this here and multiply that into this equation and see what that looks like. So You could, yeah, okay, let's try that. Let's see what that does for us. I think I need to move these networks here so they align fairly well so I can add them together. I can go ahead and close down all of those previews also in the end, but bear with me, I'm just going to make this a bit more compact so I can have them running in parallel. Here we go. Yeah, like so perhaps. And now I'll choose a multiply node. So multiply. There we go. And I'll take this result and I'll multiply it by this result. There we go. And I'll have something that looks like that. See how that's coming together? It's really starting to look like the results I had earlier, right? Yep. And not sure, but I might actually go ahead and add this value instead, because what I get right now when I'm using the multiply is I get this perfectly black area all the way down in here, and I want it to be solid white all the way in the center and just vary at the outline. And the way I would go about doing that is probably before I run my max operation here, I'd go ahead and add the value in between here. That should, in theory, if I'm not mistaken, push the outline and make sure that it gets a bit, what's it called? Not uniformly circular like this. Because even those values that are close to black here and are in negative, they might get a streak of white color from this one, and they'd be pushed into the positive space, and thereby they wouldn't be chopped off by the max operation here, which removes all negative values. So let's see what that does. I'll leave that there for now. We might go back and look at that solution as well, but let's try adding it here. Let's see, between the subtract and the max operation, and see what that does. So I'll choose an add node. I'll place that in there. I'll add this value, and I want the connections flowing from left to right, so I'll move this over here. And then I'll have a look at this, and then connect this one over here. Yeah, there we go. That's what I'm looking for. Now we have this kind of result here instead of this result. And this is definitely the way I want to go, because I want it to be this solid white color in here. We have an issue here now that it's we should be able to view this result in the viewport, right? Yep. And if you can see right now, but I don't want it chopping off here, like we spoke about earlier. So I probably need to step back on my, was it the multiplied node that pushed this value outwards? And or actually I could go for subtracting more, because I need at this point, or at this point, it needs to be black up here. And it's not. That's why I had added the subtract to begin with. So if I subtract some more, I guess I should be able to push this backwards, right? So let's try subtracting by 0.8. Whoa, okay, yeah, I did push it back, but I did push it back way too much. So 0.7 perhaps, or no, maybe 0.8 was good. I could also add a multiply node in between here and reduce the effect of these. So you can, as you can see, you can get very differing results depending on how you add and work with all of these math nodes, which is really cool if you ask me. But I do get some cool kind of effect. It's not the effect I was aiming for, so let's leave this as a good memory for any kind of future effects. But I think I'll step this back to 0.7, and I'll add another multiply in between here to reduce the effect of this one. So the add here won't have as much impact, if you will. So I'll go for a multiply node. Here we go. I'll take that multiply node, connect this result into the multiply. I'll take the other value of the multiply, and let's say 50% of that effect, or the brightness we had there. So now it's darker, and let's add that instead. And now I get this kind of effect. And as you can tell, I have quite big margin here, so I could step back on the reduce value here instead, and thereby push this one outwards. And I think I might barely be touching this one, so I might need to increase this one, this value, or decrease the effect of this one. Let's see what it looks like out here. Yep. And if I were to show the sphere out here and play this back, yeah, it's moving way too fast, but it depends on how much you want this these beams to be in length. And I think if I were to change for the noise texture that was more blurred, I might get less of these lines if I wanted more of a solid blobby kind of look. This is not exactly the look we got I had earlier to show you. I kind of like this result a lot as well, so I think we can just go with this. We could just change the texture in the end and see what that looks like. But let's say we want to just push it back a little bit, because I can see it at some points. You can probably tell up here that it gets chopped off, right? So let's decrease this one just by a little, 0.4, see what that looks like. I can still see it at some point here, peeking outside. So I need to, let's see, increase the subtract by just a little bit. Let's see what that gives us. All right, that's fairly good. You can barely tell at one little tip up here, and I think that's about it. There's one little tip down there as well, which gets chopped off, so 6.5 perhaps. I think you could actually increase this one to even more, 0.7 like that, and then instead go for increasing the multiply value here. Let's see what that does. Let's put it at 10. Yeah, no. That does increase the intensity, but I've chopped off too much of that effect. Hold on. 6.5 then. Yeah, and in the end you could make the plane bigger as well. That would be one idea, to increase the size of the plane and set the cut off mask here, and you'd have more area to play around with. But let's say we're happy with this effect as it is right now. Or actually, to be honest, I'd want to decrease this a bit and once again lower this value to get a bit more of that area. Hold on. All right. Might be barely touching there, but let's say we're happy with the effect like this. We need to just tweak the speed of this, if you ask me, and tint it in a proper color we want. You could go ahead and also use the noise texture to pan it around and do lots of crazy stuff like that, but I think it's random enough for this exercise, and I think you get the hang of how you can use this all of these different tricks with math and scrolling textures and whatnot. So I think I'll go ahead and hide all of these previews as it can impact performance. I can perhaps leave this one, and let's leave that one as well, so we can have them showing. Yep. And this multiply did give some cool effect, but not the effect we wanted, so I can go ahead and delete that one. Now, let's see, we can go to change the time, the perception of time here. So let's add a multiply node. I'll put my multiply here, and I think just to break it up even more, I'm not sure if you can tell, but when we looked at this effect, at these peaks, they appear at the same frequency, and that is because both of these are scrolling or being moved at the same speed, and thereby the same pattern of animation will repeat itself. If I just multiply time differently between these, so let's say one has a time perception of 40% time and the other one 30%, you would get more variation, more different patterns, if you will. So thereby, two multiply nodes, I can put one at 0.4, and there's no exact science to these values as usual. You probably get the idea. Just try it out, look at the result, and if you're happy with it, go for it. So now it should be moving slower. One of these should be panning at 30% speed and the other one at 40%. And you know, it's a matter of choice if you want it. If you feel this is too fast or too slow, you just go ahead and change those values. But let's stick with changing the color now and see how that's going to work out for us. Now, one way of doing it would just be to add a color node here, and we might settle for just that. You can go ahead and use 2 colors if you want. So I'll just grab a multiply node, and I'll multiply this black and white mask here with, let's see, RGB from here, yeah, like so. Oh yeah, I've managed to lock this to be just float here. So one quick way could be to do like so. I'll add this one here, and then we'll add this to this one here. I can go ahead and delete that by now, I think. Now I should be able to pick a color here. So let's say we take a similar color to this turquoise colored force field. And I think I chose something like that color, right? And you'll get this look. I think at distance you can, yeah, at some points you get the sphere scaled down so much that I get a little black edge there, and you'd have to match them if you wanted to, as I mentioned earlier. But one thing that can be nice, which you could do, is to have these beams differ a bit. So you could have them more bluer in here and tint them towards, I don't know, purple or yellow or white out here, or just add some kind of color variation. I think would give you more interesting look, because it's too uniform in color overall now. So, and also I think I'd want to increase the intensity of these lines. But let's just add the last touch of adding a second color on this one, and then we can jump back to this sphere shader. So one way to do that is to use a linear interpolate node, and then we'd have to choose one color. I might need to flip this around. A second color, I just copy pasted there. Yeah, let's go for this way, and have one of the color be differing. We can tweak this later, but let's say we go from this turquoise color to the white color. Then we need some kind of texture or mask here, which is going to choose where is this one going to add up and where is this one going to end up. And so think of it as adding a black and white mask here. And once again, we could use this, let's see, one of our masks we have going on here as our way of doing this. So it might be interesting to see what adding just this one as a mask, what that would give us. Let's try that. I don't think I've tried that myself, but let's see what that does. Yeah, might actually be that. Let's see before I make any assumptions here. Yeah, okay, that's what we're getting. So I'd want to, at this point, I'd want to probably start doing this as transparency, because in the end you want this to be transparent, because right now I have this as black. So before we tweak how we do the color, let's start by making sure this is transparent instead, as that is what we will be wanting in the end. So I'll hide the sphere again, like so. I'll select my plane. Now I want this one multiplied by that one to work as my transparency. So I think that if I choose a multiply node, I'll take this one multiplied by that one, I get this kind of result, and I will only get only the white parts will be the visible parts when it comes to transparency. So let's see, we did transparency in the last shader, if you remember. First of all, we need to add a state setting here. The state setting needs to connect to state settings. You need to set the option on the state setting node to Premultiplied Alpha blending. Then we need to exit the group. And since this is a referenced group and I changed inside, I would lose these changes if I were to save and reopen my scene. So I need to choose make group unique. Now I need to make sure that I put my alpha in the alpha channel here when I construct my vector. I also need to make sure, if you remember, we have pre-multiplied alpha. I need to multiply my RGB channel with the alpha. So I can go ahead and put this inside here. And then I can take this result as my color and multiply it here and connect to the RGB. So I think these two won't be needed. I'll take these and move them over here. I'll take a multiply node, place that over here, multiply this one by that one, you get this kind of result, and then you add that to the XYZ. Hopefully, if I've done it correctly now, I should have this one transparent, and it seems like I have it transparent, right? And this is the kind of result we're getting. Not really what I wanted, since it seems to just look like a grayish kind of look here. I'm not particularly fond with the look of this, so I think I might want to change how I'm doing my lerp, the mask I use for my lerp. So I'll go ahead and select the plane again. Here in my lerp, I want to use something different than that mix value from this one. So hold on, let's see if we look at my value I have going on here. I think I might be able to use this then as a mask instead. Let's just plug that in and see what that does for us. I might want to modify the value as well, but yeah, that's way too white. If you can tell, I only have the bluish or turquoise tint in the middle, and it goes to white way quickly. So I might want to once again use a multiply node. Take this one, multiply it so that we once again get more white. So I need to put something like 2 or 3 or a value above 1 at least to make it more intense, the middle area. I want this one to be pure white until this point almost. So I'll need to increase the multiply probably around 10 as I did here. So I don't know, let's try 10. And let's see what that does for us. There's one thing I want to mention now, and that is if you feed values lower than 0.0 or higher than 1.0 into the lerp mix value, you will get weird results. And since I'm multiplying like crazy here, I definitely have values higher than 1.0 here. So I need to add either a clamp node in here or actually a saturate node, which might not make sense. You might not be familiar with the term saturate in that sense, but saturate is, think of it as a clamp node, which is clamped from 0 to 1. So what it does is it takes any value below 0 and chops it off, so they'll end up at 0.0. All negative values will be 0.0. And if a value goes higher than 1, it will chop that off and make sure that any value higher than 1 is transformed into 1. So that will make sure that we keep our lerp node happy. So this is the kind of result I'm getting now. And that's looking better. That's more of the kind of effect I wanted. So I can, at this point, I might go ahead and try to change this one and see what that does for me. If I add something like 20, you can see, no, that's too much. Maybe something like that. And white might be way too much. I might go for something like this, just a bit brighter, and I might actually go ahead and change the hue as well, just to get a little bit different look, tinted in a different color, if you will. So maybe go towards blue or go towards more green. And now I've got this kind of look. So I'm happy with that. Let's just see if we can increase the intensity of that sphere a bit, those lines, and then I think we'll be done with the shader if I've not missed anything essential. So back to the sphere shader, and let's see. Here's our texture. I think this multiplier, let's see, this is the facing ratio, how much the surface is facing the camera. I think this multiplier, I put it here to begin with to just increase the intensity, and I have a value of 2.0 there. So let's just go ahead and try to increase that value and see what that does for us. Yeah, that's better. That's more of the look I want. See how it's starting to, no, 10 is definitely too much. It's starting to fit better with the general intensity of this one here. So, I mean, it's a matter of tweaking the values, selecting the correct colors you want at this point. You might not like the turquoise at all. You might want it more saturated, for instance, or go more towards green, or I don't know what. That's up to you. But now we've got this animated force field shader here, and it's spinning around. Its transparency is modulated by how much it's facing the camera. You've got this pattern which breaks up makes it feel a bit more alive inside here. I've got these beams out here which are driven by this procedural ramp or gradient, where we would offset the UV coordinates and then check the length to get this kind of ramp. We then used that with lots of different math to get it where we wanted and chop it off here in the middle. And we used that UV and the normalize node, that neat trick to get those wandering beams. Oh, okay, yep, it's a bit sluggish for me here. Might be time to wrap it up. I didn't save for a while here either, so yeah, there we go. That's you know when Maya is acting up, that's the cue for you to save your file. So I'm not getting that good performance here. I'm not sure if I forgot to close the playback or what's up with Maya, but I was essentially finished at this point. You used the UV set. I would offset it to have the center point in the middle, and then the normalize node would be the key node to get these kind of beams going out from the origo of the UV space. So that's about it, guys. I hope you've enjoyed this thorough breakdown and creation of an animated force field shader. Please let us know what you thought about the video and what you want to see next. To see more, visit our website or follow us on Facebook and Twitter.